So we studied about work, basic definitions, what are the formulas, and we studied one important theorem, work energy theorem, that work done by all the forces. Okay, work done by all the forces means work done by conservative forces and work done by non-conservative forces is equal to change in kinetic energy. Conservative force and non-conservative, you know, right? Non-conservative forces means like friction, air resistance, all those where energy is being lost. Those are non-conservative. Conservative means where energy won't be lost. Or conservative forces are those who don't depend on the path. Okay, all these things we have studied. Today we'll see what is power. Okay, so power is nothing but the capacity of doing work. Okay, for example, if same work a person is doing in 1 hour and one more person is doing in 2 hours, means the second person need more power, correct? So power is defined as work done per unit time. Okay, work done in unit time is nothing but power. So you know how to calculate the work, correct? So you just need to divide by the average time, how much time it is taking to do the work, then you will get power. All formulas remain same. Okay guys, any doubt here?
No, sir.
No doubt, right? Okay, all right. Then some formulas you need to remember, like for spring, okay, if it is stretched by x, the potential energy in is stored in the spring is given by half kx square. I don't want to derive this because we don't have much time. I'm directly giving you the formula. You can derive it like, you know, spring force is kx, right? So you can do it is variable force, so you can integrate kx dx. You will get this formula. Okay. Okay. All right. So these are the this is the thing you need to remember. Okay. And apart from this, energy conservation. Okay. For example, let us say there is one particle which is being taken from one position to other position from A to B. Then you can write that initial kinetic energy plus initial potential energy is equal to final kinetic energy plus final potential energy. Okay, this you have to remember. They will say that one particle was moving with some velocity and it was kept on some height or it is having some potential energy. Then it is being moved to some other position with having potential energy UF. What is the velocity? So you can use this formula. Nothing is coming in your mind, you can just go with simple work energy theorem. Okay guys, that is the basic thing, like work done you calculate and you may equate it to change in kinetic energy. You can solve 100% questions from this itself without knowing potential energy. Okay, take the screenshot.
Done, sir.
Okay, so we are done with the power and energy. Okay, so apart from this, there is nothing left in work energy theorem, work energy power chapter. You now start practicing questions, and if you feel any doubt, you can ask me. Okay. Apart from that, one more thing you have to remember is that force is nothing but du by dx. Okay, minus. If someone gives you potential energy as a function of x, let's say x square plus 2x, and if they ask what is the force, then you have to differentiate it. F is equal to minus d by dx of x square plus 2x. If you do this, you will get your force. Okay. Okay, guys. Any doubt here? This is
No,
very
sir.
important formula. Sometimes they give force and they will ask what is the potential energy change. Then you have to integrate FDX. Okay, that is nothing but again work. So from here, what you can say, FDX is equal to du, right? So here it is minus. So what is FDX? If I integrate on both sides, what is FDX, guys? Work. So work done by a force is nothing but minus of change in potential energy. This is very important formula. In electrostatics also I use this. So work done by F external force is equal to U initial minus U final. Because delta U means U final minus U initial. But there is a minus sign. So UA minus UB. Okay. Initial minus final. Okay, guys.
Yes, sir.
Any doubt?
No, sir.
Okay. So that's all. That's it. We don't need anything much to discuss about this work energy theorem. Okay. So, shall I start with the next chapter? Next
Okay,
mechanics
sir.
chapter.
Yes, sir.
Shall I start? Okay. All right. So what you do is you open any module or any book, you see work energy theorem, open new chapter. You note down all, if there are any extra formulas, you note down practice questions and bring doubts if you have any. Okay. That's how we can cover the syllabus fast. So the next chapter is center of mass. Okay. What is center of mass? Anybody? Anyone knows what is center of mass? In kinematics, what we used to do? We used to say like, well, there is a car which is moving with some velocity. Okay. So if you observe carefully, like which particle of that car is moving with velocity v? Correct. The question arises, right? Because it's very huge. So then, even in NLM, we used to say a force F is acting on a car. So on which point of the car? That is important, right? So that point is nothing but center of mass. So you can replace the whole body with a single point, and that point is called as center of mass. The center of mass is nothing but the whole mass is being put at only one point. That is called center of mass. Okay, so the center of mass, for example, for any body, so let us say we have any body, so the center of mass will be having some x coordinate and some y coordinate, right guys? Hello?
Yes, sir.
Yeah, so it will be having some x and some y. That is called x center of mass and y center of mass. Mostly they'll ask this only. Calculate what is x center of mass and y center of mass. Okay, and we can denote it with a position vector r center of mass. Okay, now how to calculate x center of mass? Simple formula is m1 x1 plus m2 x2 and so on divided by m1 plus m2 plus m3 and so on. Similarly, y center of mass, how you can calculate is m1 y1 plus m2 y2 and so on divided by total mass m1 plus m2 plus and so on. Okay, please take the screenshot.
Done, sir.
Okay, so now, so you can write that r center of mass as x center of mass I cap plus y center of mass j cap. Okay, so let us say one example. One example will do. Let's say there is a 2 kg mass and there is a 3 kg mass and there is a 4 kg mass. So where is the center of mass? So for that, let's say this point, this mass is at 1 comma 2. This point is at 1 comma 1. This point is at this is 2 comma 1, and this is, let us say, we have at 3 comma 3. Okay. Now we want to calculate what is the center of mass. So for that, what you need to calculate x center of mass first. What is m1? 2. First you add all the masses. 2 plus 4 6, 6 plus 3 7. You keep 7 down. Then start multiplying the mass with the x coordinate. 2 into 1 plus 4 into 3 plus 3 into 2. You calculate whatever comes divided by 7 is your x center of mass. Similarly, you calculate y center of mass. Divided by 7 you keep, then 2 into 2 plus 4 into 3 plus 3 into 1. Okay. So here also whatever you get divided by 7. So whatever the value you get, that will be x center of mass I cap plus y center of mass j cap. That will be your r center of mass. Okay.
Done, sir.
Done. Any doubt so far?
No, sir.
No doubt. Okay. All right. So okay. After this, what about if there is, see, they, so far what we have seen is there are unique different single masses. We call them as a discrete. But what if there is a continuous mass distribution? Okay. For example, if I take a rod, okay, where will be its center of mass? At the middle, right? So if the figure is geometrically symmetric, then you can find its geometric center. That will be your center of mass. But in general, what is the formula? So what you have to do is you consider the origin somewhere. Okay, wherever you want. I will consider at the starting point. Then what you have to do, you go at a distance x and take a small mass. Okay, small mass dm. Okay, so now the center of mass will be, its center of mass is given by 1 by total mass of the rod into integral, you have to do x into dm. Okay, any doubt? This will be the formula. And for such for linear masses, we define one linear mass density. We assume this rod to be only one dimension. So the dm is given by yeah, so the linear mass density is given by mass per unit length. Okay, this is lambda. Okay, that means for m mass, that is lambda into L, correct? So for dm mass, how much it will be? For dm mass, lambda into dx, correct? So in place of, for I'm taking just example of this rod. This is the formula for x center of mass. Similarly, y and z you can write. So now let us calculate. So 1 by m into x into dm. How can I write? Lambda into dx. Lambda dx. So you take lambda out, lambda by m into x dx. X is going from 0 to L. The length is L. Okay, 0 to L. So what is lambda? What is the value of lambda? Mass by length. Okay, into mass. X dx. 0 to L. M got cancelled. 1 by L. X square by 2 means L square by 2. L got cancelled. We got L by 2. We know, right? For a rod, it should be at the center. L by 2 we got. Okay, this is the x center of mass. Since the rod is not in y direction, the y center of mass will be 0. Similarly, z center of mass will be 0. Any doubt?
No, sir.
No? Okay. Take screenshot.
Done, sir.
Done? Okay, all right. So now you have to, remember the center of mass of different geometrical figures. That is a homework I'm giving you guys. Go find out different shapes and their center of mass. Standard list is there in NCRT, or in any book you can find it. So those things, for half circle, what is the center of mass? Or full circle, what is it? For any arc, what is the center of mass? Okay, for a cube, what is the center of mass? All those things rarely they ask in exam, but please remember those things. Okay, okay, guys. So let
Yes,
us,
sir.
yeah. So there is one important thing we have to deal with: two body system. Okay, if we have only two bodies, M1 and M2, separated by distance r, so we want to find where is the center of mass. Okay, so of course it will be between these line joining these two, right? It will be somewhere here. If M2 is very heavy, the center of mass will be towards it, right? And if M1 is heavy, then the center of mass is towards it. So what I will say, so in this such kind of situation, what you have to do is you assume that the center of mass is at origin. I said you right, you can take the origin anywhere you want. Let's say I will take the origin as this only. The center of mass itself is origin. Okay, and let's say this distance from M1 is distance of x from center of mass. So left out distance is how much? R minus x, correct? So what is the center of mass formula? I said x center of mass is equal to M1 x1 plus M2 x2 divided by M1 plus M2, correct? Now, as we said, the center of mass itself is at origin. I can keep this equal to 0. So, M1 x1 minus M2 r minus M2 x divided by M1 plus M2. So, this goes to 0. From here, you can calculate that x is equal to, you can simplify this. You're going to get it is as M2 by M1 plus M2 into R. Okay.
Done, sir.
Done. Okay, just a second. Okay. So now, what we can do? Yeah. So after this, let us solve some questions based on this concept. Okay. What kind of questions they are asking in JEE? We'll see. This is what. Oh, this is not the center of mass. Laws of motion, yeah, center of mass. See, a solid circular disk mass of 550 kg rolls along horizontal so that its center of mass has a speed of this much. The absolute value of work done on the disk to stop it is. See, what they are trying to say is there is a solid circular disk which is 50 kg rolls along a horizontal floor so that its center of mass has a speed of this 0.4. Let me solve this. So there is a rough horizontal surface and there is a solid disk of mass 50 kg, right? Which is moving with 0.4 meter per second. So they are saying that it will stop after some time. Okay. So it will start rolling. So now they are asking how much work should be done so that uh, you know so that this stops. Okay. So we know that work is equal to change in kinetic energy, correct? Work is equal to change in kinetic energy. So now, which force will stop this friction only, correct? So that only work done by friction we want to calculate. So how much work you have to do? Kf minus K initial. So what is Kf? Finally it is stopping, so it is 0. Minus what is Ki? So what is the initial kinetic energy? Half 50 into V square, zero point 0.4 square. So half into 50 is 25. 25 into 0.4 square is 0.16. So calculate how much it is 25 into 0.16. It's 4, right? So see how simple it is. Everywhere it is work energy theorem is being used. Understood this question, everyone?
Yes, sir.
Yeah. So let us see it. Why they are getting answer equal to 6? Okay. Well, so the disk is rotating also. Okay. So they are saying rolls. So I have not covered rotation. So if that was a block, the answer will be 4 joule. If it is rolling, then the answer becomes 6 joule because we have to consider the rotational kinetic energy also. That we are going to study in the coming chapter. Okay, guys?
Okay, sir.
Yeah. Uh, the momentum of a body is increased by 50%. The percentage increase in the kinetic energy of the body is. Okay, so this kind of questions, at least 2 to 3 questions you will get in the exam. The percentage change and the error, there are two concepts, those are very important. Okay. So how to solve this? The momentum of a body is increased by 50%. The percentage increase in the kinetic energy is. So see, this thing you have to remember. See, kinetic energy is what? Half mv square, correct? If I multiply by m and divided by m, what happens? Half m square v square by m, correct? So kinetic energy is equal to half. What is m into v? Momentum. P square by m. So you need to remember the relation between kinetic energy and momentum as P square by 2m. Very important formula. Okay. So in the question they are saying the momentum of the body is increased by 50%. So see, there are two methods I am going to teach you. If the percentage change is greater than 5%, okay, then you have to go with same, like use formula and solve. If the percentage change is in less than 5%, then what you have to do is, for example, let us say I will give y is equal to a square b cube divided by c cube. Okay. Then if I say, okay, there is certain change in a, certain change in b, certain change in c, then what is the change in y? If the percentage change is less than 5%, then you can directly write 2 times change in a by a plus 3 times change in B by B. If it is division, take minus 3 times percentage C by C. So this will be percentage change in Y. Okay. If it is error, you have to add all. Okay. If they're asking what is if the error in A is something and error in B is something, error in C is something, then what is error in A? Then you have to add all. But if it is percentage change, then if it is in numerator plus, if it is in denominator, you have to do minus. Okay. If the percentage change is greater than 5%, then you cannot go with this method. Then what we have to do? So here in this question, they are saying that the momentum is increased by 50%. Okay. The change in momentum is increased by 50%. Then what is the change in kinetic energy? They are asking. So you see first, what is the relation between momentum and kinetic energy? K is equal to P square by 2m. 2m is a constant, right? So can I write K1 by K2 is equal to P1 by P2 square? Okay. So in such questions where it is greater than 5%, what you have to do is K1 by K2 is equal to initial value take 100%. Okay. Final value take how much is increased. 50% increased, you write 150. Okay, whole square. 0, 0 got cancelled. From here 5 to the 5 3 is. So K1 by K2 how much you got? 4 by 9. So this first you have to calculate. Wherever they are asking, first you need to find the formula, then relate them and do this. Calculate the ratio first. Okay. So once you get the ratio, what is the percentage change in kinetic energy? They are asking. That is nothing but K final minus K initial divided by K initial, right? So that is nothing but K2 minus K1 by K1. If I divide, it will be how much? K2 by K1 minus 1. So what is K1 by K2 is 4 by 9. That means K2 by K1 is 9 by 4. 9 by 4 minus 1. From here you will get how much? 5 by 4. Okay guys. So this will be your answer. In percentage if you want, multiplied by 100. 4 2 is 2 5 is 100. 100% there will be change in. Okay guys. Understood?
Yes, sir.
Yeah, so what will be the answer here? 100%. Check answer. Oh, it is 125. Did we do any mistake? What is increasing? Percentage increase in the kinetic energy. There is our solution. So 4 by 9 we got, right? So it will be 9 by 4. 4 9 minus 4 is 5. 5 by 4. 5 by 4, 4 2s. Oh, I did mistake here, no? 5 by 4 into 100. No one is telling, simply sitting. 4 into 4 to the 8 and then 2. 4 5 are 20. So 25 5 are 120. Understood, right?
Yes, sir.
Yeah, so this is how you have to solve. So, okay. So you go to this website and practice related questions. Okay, if you get any doubt, you ask me and I will respond. Okay, I will live in WhatsApp. So that's it for today, guys. I have my mom's birthday, so I have to go. Okay, so I am closing the class a bit early. Tomorrow I'll take little bit more. Okay, guys.
Yes, sir.
Okay, sir. Yes, sir.